Hey everyone, welcome to the TSR Tech University. Myself Raghav. As part of this video, we would want to teach you the binary search algorithm. Let's know more about the binary search algorithm. Binary search is a widely used and efficient searching algorithm for finding a specific target element in a sorted array or a list. It works by repeatedly dividing the search interval in half, discarding the half that cannot contain the target element until either the target element is found or the search interval becomes empty. Let's divide the algorithm into 5 steps and try to understand one by one. Step number 1, initialization. Begin with the entire sorted array or list and define two pointers, low pointer and high pointer. They both represent the current search interval. Initially, low points to the first element and high points to the last element. Step number 2, midpoint calculation. Calculate the midpoint of the current search interval using the formula mid equal to low plus high divided by 2. This will give you the index of the middle element. Step number 3, comparison. Compare the element at the midpoint, so that is array of mid, with the target element you are searching for. If array of mid is equal to the target element, the search is finished. Return the index mid as the position of the target element in the array. If array of mid is greater than the target element, update the high pointer to mid minus 1. This means you discarded the right half of the current interval. If array of mid is less than the target element, update the low pointer to mid plus 1. This means you discarded the left half of the current interval. Step number 4, repeat. Repeat the steps 2 and 3 until one of the below two conditions are met. So the target element is found, that is array of mid is equal to the target, or the low pointer becoming greater than the high pointer, indicating that the search interval is empty and the target element is not in the array. Now let's look at the pseudocode of the binary search algorithm. Let's assume that the function name is binary search. This function takes two arguments. First argument is array of values and the second argument is the target that you're looking for. Like we had already discussed, we take two variables, variable low and high. Low we assign with 0, high we assign with length of array minus 1. Now we run a while loop. The condition for while loop is low less than or equal to high. Inside this while loop, first we need to calculate the mid. So the formula is low plus high divided by 2. And we need to go through few conditions. If array of mid is equal to the target, then we found the mid. We need to return that mid. If this condition is not met, we need to check if array of mid less than target. If this condition is met, so then we need to update the low with mid plus 1. Even if this condition is not met, then we need to update high with mid minus 1. This will be running until the whole array will be exhausted. If the array is exhausted, then we understood that key is not found. We need to return minus 1. That is an error signal. Now let's talk about the complexity aspects of the binary search algorithm. Let's first look at time complexity. Binary search has a time complexity of order of log n in the worst case, where n is the number of elements in the array. This makes it significantly faster than the linear search for large data sets. Now let's look at space complexity. Binary search has a space complexity of order of 1, meaning it uses a constant amount of additional memory. Let's talk about use cases. Binary search is highly efficient and fundamental algorithm used in various applications such as searching and databases, optimizing code, and more. However, it requires that the array be sorted beforehand, which is the key requirement for its effectiveness. Thank you all. Thank you for watching. If you like the video, please share, like, and subscribe.